All right, so let's go ahead and do 7.5, number 6 here. So my center has an x value of -1 and a y value of 0 since there's no k there present. So that's the center of my ellipse. So I'm going to draw a dot at -1, 0, which is like right there. The x radius is going to be 4, so I'm going to go 4 to the right and left from that. Go ahead, 1, 2, one more. Put a dot here, put a dot there. And my y radius is the square root of this number, which is 2. Up 2 and down 2 from my center. Put a dot there and there. And then when we connect all 4 of those outer dots together, that's what my ellipse will look like. All right, so now in this particular case, I think it would probably be easiest if we got the y by itself because it has less stuff in the way. So the first thing I would do is I would subtract this x expression here on both sides. Move that to the other side. Now we get y squared over 4 equals 1 minus the whole thing there. And then I would multiply everything by 4. So times 4 here, times 4 here, times 4 here. That way I can get rid of this 4 over here. So the y squared is now by itself. And that leaves me with 4 minus, and then 4 over 16 here reduces. End up with this whole thing being over 4 now. And then finally we take the square root. And when you take the square root, what's going to happen is the little 2 there is going to go away. And we square root on this side, and we get a plus and a minus. Now, since I solved for y, to find the area of this ellipse, we're going to be integrating with respect to x. So when you solve for y, you're integrating with respect to x. And when you're integrating with respect to x, then you're thinking of this as a function with a top, which represents the positive version of your square root, and a bottom. So 2 separate functions, one's top and one's bottom. Pink represents the positive, green represents the negative, right? So now I want to integrate this function. The top is the pink one, so that's the positive one. Oh, you know what? I wonder if what you were confused about, Christian, is because I put a 2 here. That shouldn't be there. So that's probably why you were confused. But I'll finish solving the problem just in case anyway. There's not supposed to be a square there. So we have x plus 1 squared over 4. So that's the pink one. So we do top minus bottom. So the bottom is the negative one. So that's going to be negative, and then the same thing there. Although I've written wrong now as well. I got what I had earlier. That. And then minus the negative one. So it looks exactly the same. It's just that it has the minus in front. And actually, since we're subtracting a negative, this just becomes a plus, right? And since we're adding 2 of the same thing, really, we could just combine these into 1 and put a 2 in the front of the whole thing. Since it's that square root plus itself, that means you just have 2 of those, right? And we're going to integrate that with respect to x. Now we need to know what our limits are. And our limits are -5 and +3. So the bottom was -5 and the top's +3. So that's what should be there. I should not have that little square there. So if that's what you're confused about, then my bad. All right, let's move on to your next question from this one. Okay, so it says the function below consists of a linear function, f of x equals x, that's this straight one here, and a square root function given by this equation here, which is that one. It says write, but don't evaluate. So in other words, we're just going to write the equation out. We're not going to actually solve it. Write an integral expression with respect to x that represents the way to find the region between the two functions and the x-axis. This will require two separate integrals. So this is a lot like the one that you asked about in lesson 7.4. We would have to split this up into two separate integrals. So we're going to have to do one where we find the area between the linear function and the x-axis. And then we'll have to do another integral where we find the area between the x-axis and that square root function. So for the linear one, we're going to integrate from 0 to 2. And I'm just going to put the f of x right there. And that will find you the area of the pink region. Next, the area of the green region starts at 2 and ends at 6. That's integrating this g function. And when you add those two regions together, you get the total area. And that's as far as we need to go with it. Move on to number 9. All right, so it says this same graph here can be written in another way, where instead of writing this as f of x and g of x, we could think of this side as f of y, and this side as g of y. And you could do that just by, solving for the opposite variable. But anyway, we can find this integral a little bit differently. If we are writing these functions in terms of y, then that means we're going to be integrating with respect to y. And when you integrate with respect to y, your limits are y values also. So my lowest limit of this shaded area is right here. That's at 0 for the y value. And then it stops up this high, and that's at 2. So we're integrating from 0 to 2. And now we need to find the area between these two curves. So when you're integrating with respect to y, the one that's farther to the right is the greater, and the one that's to the left is the lesser. And so it's going to be g minus f. And that same integral will also find you the area under the curve, but instead of being two separate integrals, it's just one, because we're integrating vertically instead of horizontally. So the point of 8 and 9 is to show you that there's two different ways you could do this. You could do it with respect to x, or you could do it with respect to y. And in this case, if you're doing it with respect to y, it's actually a little bit simpler because there's only one integral that you actually have to calculate, as opposed to with the x one, you have to do separate integrals. All right, let's go ahead and move on to 7.6 then. So we want to find the area enclosed by these two curves on this interval without using a graphing calculator. So first of all, we need to find all the places that these two curves intersect. And the way that you do that is, as you know, is we're going to set those two functions equal to each other. Now, there's a couple ways to do this one. I don't know, I guess for me the easiest one would be just to divide both sides by cosine like this, which would be giving us the fact that sine x over cosine x equals 1. And the reason I would do that is because this actually is an identity for tangent. That's one way to solve it. So basically, I just need to find where does tangent of x equal 1. And if you know your unit circle, there's two places that happens on the unit circle. Tangent of x equals 1 right here in the middle of quadrant 1. And it also equals 1 right down here in the middle of quadrant 3. And so that is at pi over 4 and at 5 pi over 4. And so those are our two solutions to this system of equations, which means that that's the place where these two graphs would cross at pi over 4 and 5 pi over 4. So then, as we're integrating, we have to start at 0 because that's my starting point. But the graphs cross at pi over 4. So that's where that first integral is going to end. And then we need to do a new integral after that. It starts where that one left off. And it's going to keep going until we get to our next place where they cross, which is 5 pi over 4. And then we need yet a third integral and that one picks up where that one left off, of course. And it's going to finally end at 2 pi. So we have 3 integrals that we're going to be adding together. Now the question is, on these intervals, which one comes first? So we have to know for each one of these intervals, is it f minus g, or will it be g minus f? And it all depends on which one is greater than the other on those intervals. Now really you only need to do one of these, because once you do the other ones, it just kind of flips back and forth. So let me show you what I mean. So let's pick a nice radian value between 0 and pi over 4. So 0 is right here on the unit circle. Pi over 4 is right here. So a good one in between them would be pi over 6. Okay. Now pi over 6 is right here. And that point has the coordinates of radical 3 over 2 for the x and 1/2 for the y. And that would be the cosine value, and that would be the sine value. Okay, so if I pick a number on that interval between 0 and 4, f of pi over 6 is equal to sine of pi over 6, which we've already said is 1/2. And g of pi over 6 is equal to cosine of pi over 6, which we've already said up here is equal to radical 3 over 2. And radical 3 over 2 is bigger than 1/2. If you change this into a decimal, you see it's like 0.86, whereas this was 0.5. So g is bigger. So since g is bigger, g comes first on this interval. And then the next interval will be the opposite. It'll be f minus g. And the next interval will be g minus f. Now that's the hard part. That's the setup. The rest of it is review. It's stuff where you just have to do the fundamental theorem of calculus to get the problem done. Okay, so let's go ahead, and what I think I'll do here is I think I'm going to replace these now with what they actually equal. I don't have a lot of screen space, so I'm just going to delete what I wrote here. So instead of putting g minus f, I'm going to put cosine minus sine. And then in the next spot here, I'm going to put the opposite, which is sine minus cosine, because it flips. The other one will be like the first one. Sine minus cosine. And I'm leaving the x out and stuff just for space, but there's supposed to be an x in there. Okay, so what we're going to do is we're going to integrate these now. So let's integrate that. The integral of cosine is sine. And the integral of sine is negative cosine, but since there's a plus there, a minus here, that negative, this minus sign plus the negative this creates when you integrate it becomes a plus. That's going to become plus. And we'll just kind of keep doing that for the other ones as well. The next one, when you integrate sine, you're going to get negative cosine. And when you integrate negative cosine, well, when you integrate cosine, you get sine, but there's a minus there, so that minus is really just the same thing, just opposite signs, which we would expect to happen. Switch the order of the functions, really. And then finally, this last one here, I'm going to see if maybe erase 5 over 4, so it's out of our way. what it was. And now we integrate this one, and this one's going to look like the first one because it's the same function, really. It's going to be sine x plus cosine x. And we're going from 5 pi over 4 . All right. And as you know, basically we're just going to be plugging these in and evaluating them at this point. And that's quite a bit of space. And so I'm going to go ahead and type it because I'll have more space if I type it out. Type smaller than I can write. So we're going to have sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. So that's my entire first integral there. Shift that up a little bit better. There's my first one. All right, and we'll continue the journey here. All right, as for this next one, we're going to do the same thing, but this time we're going to be plugging in these two numbers into this here and subtracting those. So negative cosine of 5 pi over 4 minus sine of pi over 4 minus cosine, negative cosine of pi over 4 minus sine of pi over 4. And that takes care of the second integral. And I'm still running out of space. All right, so we need to do the same thing with this one here. Type it really tiny or something. Got the idea. I'm still going to go ahead and if I could squish it in here a little bit. So on this one, we're going to plug in 2 pi. So we have sine of 2 pi plus cosine of 2 pi minus sine of 5 pi over 4 minus, plus cosine of 5 pi over 4. All right. Barely squished. Right. Okay, it's a little bit off the screen, but you got the idea there. All right. So now we're going to go ahead and evaluate each one of these things. So here. Maybe you'll be able to write a little bit nicer than me. Hopefully I didn't make any boo-boos here. There's a lot of room for an error. Especially when you're not being very neat like I am right now. All right, let's see. So now you have to know your unit circle to be able to answer these. But sine of pi over 4 is radical 2 over 2. And so is cosine of pi over 4. Sine of 0 is 0. And cosine of 0 is 1. So there's our first one. The next one. All right, so cosine of 5 pi over 4, that's negative radical 2 over 2, but there's a negative in front here also, so they cancel, and you end up with a positive radical 2 over 2, minus sine of pi, this should say 5 pi over 4 right here, minus sine of 5 pi over 4, which is also negative, but that has a negative in front of it, so it also becomes a plus, minus, and then here, cosine of pi over 4 is radical 2 over 2, but there's a negative in front, so now that's a negative radical 2 over 2. And same thing over here with the sine. There's that one. And then we have this third one over here. Sine of 2 pi is 0, plus cosine of 2 pi is 1. And then sine of 5 pi over 4 is negative radical 2 over 2. And we're going to add to that another negative radical 2 over 2. So if you add a negative, it's just going to be minus. All right, and then you're going to go ahead and do any kind of distribution that you need to do here. So I do need to distribute, let me change the pen. I'm going to need to distribute this negative in here, and we can get rid of the zeros. They don't matter. I need to distribute this negative here, and we can get rid of this 0 here and distribute this. So after you do all those distributions and get rid of all those zeros, you're going to have radical 2 over 2 plus radical 2 over 2 plus 1 plus radical 2 over 2, radical 2 over 2, plus radical 2 over 2, and so on. A lot of radical 2 over 2's here. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8 of these radical 2 over 2's. So if you were to add all those together, you're going to have 8 radical 2 over 2. 8 radical 2 over 2. And we also have a 1 here and a 1 here, which makes 2. And then this divides to make 4. Now, it's possible I made a mistake here. I don't know if that's what the answer key says or not, but hopefully you have the idea. There's just so many room for mistakes, especially when I'm not able to write very neat on my little computer here at home. So it's all squished in. And when I'm not neat, I'm much more likely to make mistakes. Hopefully I didn't do that, but hopefully you got the idea there. So the principle there is basically to find where they intersect, and that's at pi over 4 and 5 pi over 4. Set up 3 integrals, integrate, and plug and chug from there. Okay, so hopefully that was helpful to you, and we'll see you in class later.